Hey everybody, in this lecture I'm going to be solving some problems that involve friction and the equation for friction and the coefficient of friction. So let's get started. A 4.0 kilogram desk is dragged across a horizontal floor at a constant velocity. The applied force is 30 newtons. Find the coefficient of friction between the desk and the floor. So let's start with the free body diagram. The downward force is mg. So that's going to be 4 times 9.8. Gives me 39.2 newtons. There's an upward force, the normal force, or the normal reaction force. I'm going to call it R. And it's a constant velocity, so I know R is equal to 39.2 newtons. The forward force, the applied force, is given as 30 newtons. Should be 2 sig figs, really. And since it's a constant velocity, I know that my frictional force of friction, has to cancel out applied, so it's also 30 newtons. We want to find the coefficient of friction, so we'll use our equation. Friction is mu times the normal force. Mu is equal to, divide both sides by R, force of friction over the normal force. Force of friction, we know, is 30 newtons. Normal force is 39.2 newtons. So mu is equal to 30 over 39.2. Plug it into a calculator. My coefficient of friction is 0.77. Has no units because the newtons cancel. Next problem. At the bottom of a ski slope, a 56 kilogram skier slows to a stop on horizontal snow. Find the acceleration of the skier if the coefficient of friction between the skis and the snow is 0.36. So it's the bottom of a ski slope and it's horizontal snow. Let's draw a free body diagram. It's a 56 kilogram skier, so mg is going to be 56 times 9.8. Which is 548.8 newtons. I'll round at the very end to 2 sig figs. My normal force is pointing up, and since the skier is moving horizontally, that has to cancel with gravity, 548.8 newtons. The skier is slowing to a stop, so there's no force pushing the skier forward anymore. If they're moving to the right, that means the friction force points to the back. And we aren't given what the frictional force is. But we're given that the coefficient of friction is 0.36. So mu equals 0.36. And we want to find the acceleration of the skier. Well, if mu is equal to 0.36, then we can solve for FF, because it's just mu times the normal force, which is 0.36 times 548.8 newtons. It's going to be about 197.6 newtons. I'm going to label that in my diagram and underline it, 197.6 newtons, so I know I calculated it. We want to find the acceleration. This is our final goal. So I'll set up Newton's second law. Sigma F equals ma. There's only one force, it's friction. The force of friction is mass times acceleration, which means the acceleration is just the force of friction over the mass. 197.6 newtons over 56 kilograms. 197.6 over 56. I get 3.52 meters per second squared. And to correct sig figs, it's 3.5 meters per second squared. Fill in the forces that you know. Set up Newton's second law.